All right, everybody, welcome to Math with Grace.
For this video, we're going to be going through Relations and Functions, Book 1206, Lessons 4 through 6. Section 4 begins on page 26, and it's titled Law of Sines. We did Law of Cosines in the last video, now we're doing the Law of Sines. Another formula that is used in solving primarily oblique triangles is the Law of Sines. And here is the basic rule for the Law of Sines, that the sine of A, angle A, over side A is equal to the sine of angle B over side B is equal to the sine of angle or side C over angle C over side C, where A, B, and C are the angles opposite the sides. They're same sides, okay? So looking at this proof here is how they determined, this right here is how they determined that formula, okay? It says the law of sines is usually used in the solution of a triangle when the following parts are known already. Two angles and a side opposite one of them. So if we knew angle A and angle C and either side C or side A, or two sides and an angle opposite one of them. So if we knew side A and B and angle B, then we could use this formula, okay? Up to the top of page 21. Or 27, sorry. When using the law of sines, certain conditions are present that produce a solution for one triangle or two triangles or possibly no triangles. The following chart summarizes these possibilities. If we are given side A, side B, angle A as an acute angle, and then here's the thing, right? Side A is less than B times the sine of A, then there are no triangle possibilities. If A is equal to B times the sine of A, then one triangle is possible. If B times the sine of A is less than A, which is less than B, then two triangles are possible. And if A is greater than or equal to B, then one triangle is possible. If we are given A, B, and angle A as an obtuse angle, so larger than 90 degrees, right? If side A is greater than side B, then one triangle is possible. If side A is less than side B, no triangles are possible. All right? So it says a sketch of the triangle is recommended using the given information to indicate which possibility might exist. So for this example, find the length of A of the given triangle. So they've given us this triangle. We've got a bunch of information. They want you to find the length of A. Well, we are going to use the law of sines so that the sine of 30 degrees over the length of A is equal to the sine of 45 degrees over the length of 10. Okay? Finding out our different measurements is very important. For this one, they decided to use the fractional equivalence, right? Well, remember in book 1203, we had that chart that helped us with the fractional parts, right? So the sine of 45 degrees is the square root of 2 over 2. The sine of 30 degrees is 1/2. That's why I say to make copies of this information, okay? This information helps us throughout all of everything. So make sure you have a copy of that somewhere because the fractions are easier to work with in this particular problem. So we come down to A equaling 5 times the square root of 2. All right, once we do the math. Let's turn the page. Now there's an example starting on page 28 that goes on to page 29. And they want you to find all of the information. They want you to find all of the angle measurements. They want you to find all of the sides. And that is doable with both the sine, with the sine function that we were learning. But and I'm not going to go through the whole thing, but I want you to look at is right here, when they determine that the sine of B is 3/4, therefore it's 0.75. And so they've delineated that B is 49 degrees. And if we look at our book, we'll see that 49 degrees, since we're on the right-hand side, we have to come up from the bottom, is about 0.75, right? Approximately. But what I want us to look at here is it says here, right, that here, and so they finish solving. I don't want to make this confusing, but they finish solving for the other missing parts using B being 49 degrees. And I assume that's what this dot means over all these equal signs, that there's a possibility of another answer, because it says here that if B is 49 degrees and we subtract 49 from 131, or from 180, we get 131, which also has a sign of 0.75, okay? Now, we don't have that on any convenient chart that you are going to find, but 131 degrees, the sign of 131 degrees is also 0.75. So what they did was they took the original finding and subtracted that from 180, and now they're saying that 131 degrees is B. Well, if B is 131 degrees, okay, that changes the length of our side C and the length of our measurement for C, okay? And so then we have to solve for those two new answers, because both of these are possibilities for these original measurements that they gave us. Now, I have gone through the problems and I don't remember seeing one where this applies, but I want you to make note of it in case it comes up on a quiz or a test, okay? Let's look at one more example. So it says to find the distance from an observer's point A, so someone's standing here, okay, on one side of a river, to the point P across the river, a line AB, this line here measures 2,540 feet, right, was laid out on one side, and the angles BAP were measured, found to be 47 degrees 20 minutes and 78 degrees 10 minutes respectively. And they want you to find the distance from A to P. Now, we've done these kind of problems in the past, right? But when we did them last time, we actually made a 90-degree angle. But that's not the information that we're given, right? So right now we need to find this distance right here, which they've labeled D, which with all their other stuff, you would think they would just label it side B. But, okay. First thing they found was that angle P is 54 degrees, 30 minutes. I'm going to erase this because I don't want that to be a confusion, because we're not using that right angle right now. Then they could use the law of sines. We needed angle P because we have side P, so to speak, right? So this was 54 degrees, 30 minutes, and it goes along with this 2,540, right? Then we could say that the 78 degrees, 10 minutes went with what we were missing. In these occasions, they actually solved for the decimal because it was easier to work with. You could use your book or your photocopies to do that, just to find the decimal equivalent and then solve for D. And you find out that from point A to point P is 3,054 feet. Okay? So that's the law of sine. Let's do a couple of these problems together. I'm just going to use the note page here to do the work. For number 1, given triangle ABC, A equals 18, angle A is 45, B equals 105. They want you to find side C. So I'm just going to draw a rough triangle. I will label this angle A, which was 45 degrees, and therefore side A is over here, which is 18, and angle B, sure, okay, 105. It really doesn't matter, right? But they want us to find side C, which is this side here. Well, to do that, I need to know angle C, right? I know angle A and B, so I can easily find angle C. Together, these equal 150, so C must be 30 degrees, right? 180 degrees is all that's available in a triangle, so that's where we end up. So we have the sine of 45 degrees over 18 is equal to the sine of 30 degrees over C, because that is what we are looking for. I'm going to go ahead and use the fractional portion of this for this problem. I'm going to slide over a little bit here. So the sine of 45 degrees is the square root of 2 over 2 all over 18, right, is equal to the sine of 30 degrees, which is 1/2, all over c. Now, this is a proportion, so we just need to cross multiply. So I have c times the square root of 2 over 2 is equal to 1/2 of 18. Okay? I'm not going to worry about this right now. So c times the square root of 2 over 2 is equal to 9, right? To get rid of this fraction, we're going to multiply both sides by the reciprocal, right? Or 2 over the square root of 2. This cancels all of this, right? And so now I'm left with c is equal to 9 times 2 over the square root of 2, or 18 over the square root of 2. Now, that is not an appropriate answer because we have a radical in the denominator, right? So I'm going to multiply it by a 1, basically, but in the form of the square root of 2 over 2, square root of 2 over the square root of 2. And that leaves me with 18 to the square root of 2 over 2, but that can be reduced here, right, to 9 times the square root of 2, right? 2 goes into 18 9 times. So my c is, that's all I want you to find c. C is equal to 9 times the square root of 2. They don't give us any unit of measure for our distances, so I don't have anything I can put there. Let's take a look at 4.6. Given B is 600, angle B is 11 degrees, angle C is 75 degrees, in triangle ABC, find AA and C. They want you to find all the other parts. So here's my triangle. I have B, I'll make this B, and it's 11 degrees, and side B is 600. I also have side C, which is 75 degrees. This would be, or angle C, this is side C, this is angle A, and this is side A. How much is angle A? That's the first thing we can solve for, right? It's one of the easiest. These two added together give me 86. 180 minus 86 is 94. So angle A is 94 degrees. So now I need to find the other sides, okay? So let's start with the sine of A, which is 94 degrees, over side A, equal to the sine of 11 degrees over 600. Okay? Now again, this is a proportion, and we can cross multiply. So I have A times the sine of 11 degrees. That is obviously not going to be on our fractional chart, so we need to look it up. Let's see here, 11 degrees, the sine of 11 degrees is 0.1908, and that's going to, oh, sorry, I'm off screen. Okay, that's going to be equal to 600 times the sine of 94 degrees. 94 degrees goes off my chart, right? My thing only goes up to 90 degrees, so we got to pull out a calculator for this one. So here's my trusty calculator, and I'm just going to push the sine button, and a 94, close my parentheses, equals, and I get 0.997. Now here I'm going to have to round, right? So 756. I'm rounding my 5 based on my 6, so it's going to go up to a 6. So there we are. So now I have A times 0.1908 equals, what is 600 times this? Well, I'm going to re-round it here. So 600 times 0.9976 equals 598.56. I'm going to divide both sides by 0.1908. 908. And that gives me just my A by itself, right? So divided by 0.1908. Oh my goodness. Okay, 1908 equals, my A is 3,137.1, and I'll just leave it at that. So that makes sense, right? Because if my 11 degree angle made a 600 degrees or 600 length side, my 94-degree angle should make a pretty big side. So 3137.1. Again, I don't have feet or whatever my unit of measure is for that, but that is our answer for side A. And the last thing we need then is side C. Now, I'm going to obviously do the same sine thing, except I'm still going to use B, because B was the one thing we had all the measurements for. So the sine of 11 degrees over 600, there's no rounding involved in that. That was the information we were given. Is going to be equal to the sine of 75 degrees over C. Again, proportion mean we get to cross multiply. So C times the sine of 11, which we've already figured out as 0.1908, is going to be equal to 600 times the sine of 75 degrees. I'm going to grab my book for this one. 75 degrees, I'm on the right-hand side, so I'm going to come up from the bottom. So it's 0.9659, 0.9659. Okay, so now let's do the math. I've got C times 0.1908 is equal to 579.54. Dividing both sides by this decimal, 0.1908 tells me that C is equal to 3037.42. So I'm just going to say 4. Right? So C is 3037.4. Okay, so we're setting up a proportion, we're solving, cross-multiplying and solving. Drawing the picture is a huge benefit and help on these. Do not underestimate how important that is. All right, good job. That's lesson 4. Lesson 5 begins on page 34, and it's not even really a lesson. It's just more applications of what we've been learning in this book, okay? These additional problems will use the concepts in the previous sections. You are strongly urged to solve these problems in the following manner. Draw a diagram. Decide your process, whether it's a trigonometric function, the law of sines, or the law of cosines. Set up your equation and solve. Okay, so it's really just story problems from here on out. Let's look at number 1. A jet bomber flies north at a rate of 650 miles per hour, or knots, sorry, and another one flies west at a rate of 600 knots per hour. If both started from the same place at the same time, how far apart will they be in 3 hours? How far apart is this? Okay. Well, distance equals rate times time, right? The time is 3 hours. So we need to multiply both of these by 3. These numbers are going to be fairly big. So 650 times 3 is 1,950, and I'm just going to put in parentheses so I don't lose it. And 600 times 3 is 1,800. We have a right triangle here. We are looking for the hypotenuse. This is just the Pythagorean theorem, right? So 1,950 squared plus 1,800 squared is going to equal x squared. Okay, these numbers are going to be huge right now. 1950 squared is 3,802,500 plus 1,800 or 3,240,000 equals x squared. Adding those together, we have 7,042,500 equals x squared. We take the square root of both sides, and we find that x is equal to 2,653.77 2,653.77 miles. Okay. Oh, that's a huge number problem, but that's just what these are. These are just going to be story problems. So let's take a look at another one. So flip to page 36. I'd like to look at number 10. Number 10, it says an automobile weighing 2,000 pounds is held stationary on a hill by its brakes. The hill angle is 20 degrees 30 minutes. Okay. With the horizontal, which is just the ground. To hold back the car, the brakes have to exert the same force as would a cable fastened to one end of the car and held by several men. What is the strain? I like the way this example is set up a little bit better than the block one. Here is the angle, the measurement that I'm going to draw, okay? I want X. This is my X. This is what we're searching for here. This is what we're searching for. This is parallel with this, okay? But I have a 90-degree angle here. So I have similar triangles. This is 2,000 pounds. If I continued this down, it would be perpendicular here, okay? Remember, that was how it was drawn in that example. I'm trying to draw it a little bit better way to help you understand. This same measurement is here, all right? So we are solving for X. To do that, we have a right triangle, right? So we know that the sine of 20 degrees, 30 minutes, is equal to opposite, which is X, over the hypotenuse, which is 2,000. I wrote 200 here. Sorry, it's 2,000. Okay? There's what we're solving for. So we want to solve for X, so we need to multiply both sides by 2,000. So we have 2,000 times X is, why do I keep writing 200? X is equal to 2,000 times the sine of 20 degrees, 30 minutes. I pull out my handy dandy thing. I'm on the left-hand side of the page, so I'm going from the top. 20 degrees, 30 minutes is 0.3502. 0.3502. All right. Now we do the math, and we get that X is equal to 700.4, or approximately 700 pounds of pressure. Okay. How much strain to the nearest pound, it says, is imposed on the brakes? 700 pounds to keep this car from rolling down the hill. Okay. I feel like this maybe drawing was a little easier to understand, hopefully, than the example that they gave us. But this is just a bunch of story problems. If something comes up and you need help with one of them, let me know. Otherwise, let's move on to lesson 6. And lo and behold, lesson 6 is on page 42, and it's even more story problems, but this time it has to do with airplanes, a lot more with airplanes. And so we've got a little bit more vocabulary to look at. It says the parallelogram of velocities, along with the law of sines and cosines, oh my gosh, sorry, that was jarring, I'm sure, is used to solve many problems in the field of navigation and aviation. So a knot is a nautical mile per hour, and a nautical mile is a distance of 6,080.27 feet. The heading of an airplane is the direction in which the plane is pointed. Due to the wind, a plane does not always go in the direction it is pointed. So looking at this drawing, its heading is B, okay? This direction. That's the direction it's pointing. The track of a plane is its actual path. As it's getting pushed by the wind, right? It doesn't actually go in a perfectly straight line. The course of a plane is the direction of its path. Airspeed of a plane is the speed in still air. So if there's no wind. The ground speed of a plane is its speed relative to the ground or water over which it flies. A tailwind is one that blows in the same general direction of the flight. A headwind blows in the opposite direction of the flight. And it says here, looking at this drawing, the airspeed shown in the preceding figure combined with the wind velocity of AC, so this is the wind, okay, gives AD the ground speed and the direction of the flight. So the plane is trying to go this way, but wind is pushing it, so it's actually, it's facing this way, but it's traveling like this, okay? The angle BAD is called the drift angle. How much is this plane drifting with this flight, okay? And it says in modern navigational practice, courses and bearings are generally measured clockwise from north and range anywhere from 0 to 360 degrees. The following headings or bearings are illustrated. So if a plane is headed at north 42 east, you start at north and you go 42 degrees to the east, okay? If a plane is heading at south 73 west, you're starting at south and going 73 degrees to the west. If a plane's heading is 135 degrees, you always start at north and go around to 135, clockwise, it said. Same thing for this 330, right? And here it's going, number E, is north 28 degrees west. So you start at north and went 28 degrees to the west. All right, so that's just some general examples. Let's flip the page. Let's look at the example at top of page 44. Find the course, ground speed, and drift angle of an airplane headed at 140 degrees. So it went, there's its 140 degrees, and there's its heading. They drew a line, okay? When flying at an airspeed of 240 miles per hour, and when a 30-mile wind is blowing from a direction of 40 degrees. So then they took, so all of this line right here could be drawn, right? We in 140 degrees, we drew this line, and we labeled it 240 because that's how fast the airplane is going. The wind is blowing, okay, 40 degrees. So they drew a line at 40 degrees like this, okay? And it is 30 mile per hour wind. So here is the 30. Well, because they made this, basically at this point we have those two lines, right? This line here and this line of our airplane. They turned it into a rectangle. Okay, remember our parallelogram, so that they could drop the 30 down here. This is a 90-degree angle, and this is what one of the things we're solving for. Okay. All right, so the diagonal OC, right? I erased some things. It was getting a little messy. Gives the ground speed and course of the plane, and angle AOC gives the drift angle. So what they want to figure out first is the measure of this angle, because we've got like our parallelogram. I'm going to pull it out here. Try to draw it kind of similar to what it has here. This is O, this is B, C, A. Split it in half here. This is 30. This is 240. Okay. They're trying to figure out AOB, which is this part right here. If we look here, we have, and they have the math here, but I want to explain it a little bit differently. This whole north to south is 180 degrees, right? If we took this 180 degrees and subtracted this 140 degrees that we know of, we'd be left with this right here being 40 degrees, right? If this piece is 40 and this piece is 40 because vertical angles are equal, then we know this whole part right here is 80 degrees, okay? That's where they were getting at with this first chunk of formula. If we know, because parallelograms work this way, that this corner of our parallelogram is 80 degrees, then we know that this corner is 100. That is how parallelograms function, right? These two corners are supplementary corners. So they add up to be 180 degrees. Okay, we already know that OA is 240 and that AC here is 30 degrees. Okay, so then they use the law of cosines to solve for the next section. And they said that OC squared, which is what we want to solve for, right, is equal to AC squared plus OA squared minus 2 times AC times OA times the cosine of angle A, which we know to be 100 degrees. All right, so then here's what they did. They did all of that, and they found that OC is equal to 247 miles. Okay, so that's what we're dealing with, law of unit of measure, miles. But we need to find, so we've just found the ground speed and course, okay? Now we need to find, or we found the ground speed. Now we need to find the drift angle and the course. Well, the drift angle is just this little piece right here. Okay, that's what we need to find, is that small piece there. For this, we're looking for this chunk right here. For this one, they're going to use the sine, the law of sines. And the sine of COA, which is the little chunk we're looking for, okay, over its opposite of 30, is equal to the sine of 100 over its opposite of 247, which we just figured out. So they were able to find that that's approximately 7 degrees. So that little chunk is 7 degrees right here. That is the drift angle. Well, if the drift angle is 7 degrees, then the course, because original course was 140, right? It's going to be 140 plus that 7. You know, our original heading was 140. We add that extra 7, and that's our course angle. Okay? So the ground speed was 247 miles per hour. Drift angle is 7 degrees. The course is 147 degrees. Okay, let's turn the page. Problem 6.1 on page 46 says that a river is flowing, sweet little river, at a rate of 2.4 miles an hour when a boy rows across it. Okay. He is rowing at still water speed of 3.1 miles per hour, and he's rowing perfectly perpendicular, and it wants us to find the ground speed of the boat. Well, as he's rowing perfectly perpendicular, right, the boat is being pushed by the current, and so this is our ground speed. Okay, we actually have a 90-degree angle here because it says perpendicular. And so really we're just using the Pythagorean theorem here. 2.4 squared plus 3.1 squared is going to equal x squared. 2.4 squared is 5.76. 3.1 squared is 9.61, and that equals x squared. Adding these, we get 15.37 equals x squared. We take the square root of both sides, and we find that x is equal to, technically, plus or minus, right? We're taking a square root, but we don't go negative speeds. So equal with a dot, because we're rounding, 3.92 miles per hour. There aren't that many more problems to do, so I'm going to let you go ahead and give those a try. If something comes up and you need assistance, please do not hesitate to send me a text message. Otherwise, until next time.